Okay, picture this. It's the final over of a T20 match. It's a real nail-biter. The bowler is under a mountain of pressure, runs in, oversteps, and the umpire's arm goes out. No ball. The crowd goes wild, and you hear that familiar voice from the commentary box. Right? We've all heard it a million times. An extra delivery, whether it's a wide or a no ball, is treated like this catastrophic error. It supposedly hands all the momentum, and probably the match, right over to the batting side. It's basically cricket gospel, an undeniable truth. But for all the expert opinions and all that passionate commentary, what do the numbers actually say? Let's really dig into this, because a recent study put this exact idea under the microscope and, well, the results are probably not what you're expecting. So first, let's just be clear about the conventional wisdom we're putting to the test. It's this idea that an extra delivery is a predictable, super high-impact event that just massively benefits the batting team. And you can totally see why this belief is so strong. I mean, in the high-stakes world of T20 cricket, the margins are razor thin. Every single ball is analyzed to death, so an unforced error that gives your opponent a free run and another chance to score, it just feels huge. Coaches spend endless hours drilling bowlers to avoid them. And just so we're all on the same page here, an extra delivery is a wide, bowled too far from the batter, or a no ball, which is usually for overstepping the crease. The penalty is a run, and you have to bowl the ball again. Simple enough, right? But is its impact really that simple? To find out, researchers basically had to become data detectives. They put together this huge data set to get past the anecdotes and opinions and find out what's really going on. And we're not talking about just a few games. They analyzed 1,581 individual extra deliveries. That is a massive sample size. It means that whatever patterns they find or don't find are going to be pretty reliable. And this data wasn't cherry-picked from one specific league either. It was pulled from 269 different T20 matches, covering men's and women's games, international cricket, and high-pressure franchise stuff. That kind of variety is absolutely key to making sure the findings are legit and not just some weird fluke. Okay, so this is where it starts to get really interesting. When the researchers actually started to crunch the numbers, the first results were, well, they were pretty surprising. First things first, they had to define what impact even means. So they broke down the result of that rebowl delivery into 5 categories. On one end, you have high impact. That's the game changer everyone talks about, 3 to 6 runs. Then at the complete other end of the scale, you have no impact, which is just a dot ball. And get this, you even have negative impact for when the batting side actually loses a wicket on their bonus ball. Now just look at this chart for a second. That high-impact slice, the big boundaries that change the game, that only happens 19% of the time. Now add up no impact and less impact. That's 2/3 of the time, 67%, where that momentum-shifting ball results in 1 run or less. A full 30% of the time, literally nothing happens. This is hardly the guaranteed game changer we're always told it is. So, okay, the outcomes are all over the place. But maybe they're predictable. To figure that out, the researchers unleashed 9 different machine learning models. Let's call them our digital detectives, to see if they could find a pattern and predict the outcome based on the match situation. And the result? Ha! The detectives were completely stumped. Just look at these accuracy scores. The very best model was only right 40% of the time. Now, keep in mind, in a test with 5 possible answers, just guessing randomly would get you 20% right. So this is barely better than a coin flip. It means there was just no obvious way to predict if an extra ball was going to be a disaster or a total dud. But the researchers didn't stop there. If the big picture was just random chaos, maybe there were some hidden clues, some specific factors that could crack the case. So the next move was to use something called feature selection. You can think of it like a detective realizing that most of their clues are just junk. They basically tell the computer, hey, ignore all the noise and just focus on the variables that seem to have a real connection to what happens next. And they did find 3 things that seem to matter most. First, the stage of the match. The end overs are obviously way different than the start. Second, the batsman's current strike rate. And third, how many runs the bowler had already given away. And these kind of make sense, right? A batter who's on fire in the final over seems like a pretty good candidate for a high-impact outcome. But this is where we see the problem. This is a decision tree, and it tries to map a clear path from a situation to an outcome. As you can see, it's a complete mess. You might follow one path for a batter with a high strike rate and it leads to high impact. But you follow another almost identical path and suddenly it branches off to no impact. There is just no clear, reliable route from A to B. The connections are way too weak and tangled up. Which brings us to our final section and the final verdict from all this detective work. Get this. Even when the digital detectives were told to focus only on those 3 most promising clues, the match stage, the batsman's strike rate, the bowler's runs, their ability to predict what would happen was still really, really poor. Now, you might be looking at this chart and see that the accuracy jumped to 69% and think, hey, that's a big improvement. But here is the massive catch. It came with very low precision. Imagine you have a smoke detector that goes off every time you make toast. Sure, it'll catch the one time there's a fire, but it'll also give you hundreds of false alarms. That's what happened here. The model started yelling high impact so often that while it was right sometimes, it was wrong way more. It's just not a reliable predictor.
So let's just put it side by side. On one hand, you have the expert opinion, the voice we hear on TV, saying extra balls are predictable, high-impact game changers. And on the other hand, you have the data, which says the complete opposite. They are random events that mostly have a low impact.
And that's the bottom line. The huge takeaway here is that while an extra delivery feels like this massive moment, its outcome is much more like a roll of the dice than some predictable swing in the game. It is chaos, not cause and effect. And for coaches and captains, it suggests that instead of panicking about a momentum shift, maybe the best thing to do is just take a deep breath and treat it like a reset.
This whole thing really makes you wonder, doesn't it? If a piece of cricket knowledge this widely accepted just crumbles under the data, how many other coaching strategies and expert opinions in all kinds of sports are just built on myths, waiting for a data detective to come along and finally reveal the truth?